Welcome back, everyone. This is Mare here. In today's video we'll be tackling this integral right here. So at this point, feel free to pause the video and try it out for yourself, and get back to the video once you've tried something out. So at first glance, traditional methods like u-substitution or partial fraction decomposition don't actually work. So you can try to set u equal to x to the third plus 1 and see that it doesn't really get us anywhere. However, there is a creative approach here that allows us to simplify this integral quite a bit, and then a traditional technique will actually work out quite nicely. So the first thing that we have to notice here is that we have this x to the third plus 1 expression, as well as this third root here. So the first step is going to be factoring out an x to the third out of this expression, which will be x to the third times 1 plus x to the negative third, since x to the third times x to the negative third is just 1. And this is all squared. Since x to the third squared yields x to the sixth, and that's all within this third root here, we can pull out an x squared. And so we can rewrite this as the integral of 1 over x squared, which was there before, times another x squared, which we pulled out by essentially canceling this x to the third here. And then we still have this third root here of 1 plus x to the negative third squared. And then we can combine these two terms here, because x squared times x squared is just x to the fourth, so we can rewrite that as well. So it's 1 over x to the fourth times the third root of 1 plus x to the negative third squared. I've been forgetting to put my dx here on the end, but be sure to remember that. So we'll move this over here, and now since x to the fourth here is on the bottom, we can put it to the top and make it x to the negative fourth, since that is an exponent rule there. So it's x to the negative fourth on top over the third root of 1 plus x to the negative third squared dx. And at this point, we can actually employ quite a nice little u-substitution that will allow us to solve this integral. So as you guys can tell, this integral has simplified to some degree. However, it still looks a little bit tricky. However, there's quite a clear little u-substitution that we can actually do now, and that will allow us to solve the integral. So we can actually set u equal to 1 plus x to the negative third. And then therefore, du equals negative 3x to the negative fourth dx. That's just the power rule right there. And therefore, dx equals du over negative 3x to the negative fourth. And that is very nice, because now we have this x to the negative 4 term here and this x to the negative 4 term here that can actually cancel. And so we can plug all of this back into the integral. So we'll get the integral x to the negative fourth over the third root of u squared. And then we have du over negative 3x to the negative fourth. And then we can clearly see that these x to the negative fourths just cancel out, and we're just left with this single u term here. And we can also pull out this negative 3, or negative 1/3. And since everything cancels so nicely, we can rewrite this integral, pulling out the negative 1/3, and we're left with 1 over the third root of u squared, which is just u to the 2/3 based on exponent rules, all with respect to u. U to the 2/3 on the bottom is just u to the negative 2/3 du, and the antiderivative of u to the negative 2/3 is 3u to the 1/3, and we multiply that by the negative 1/3 out front, and we add plus c at the end. And at this point, we can multiply this into here, and we're just left with negative u to the 1/3 plus c. And since, I'll bring this up to here, and since we set u equal to 1 plus x to the negative third, we can just plug that back in for u. And so negative 1 plus x to the negative third to the 1/3 plus c, which can also be written as the third root of 1 plus x to the negative third plus c, and it's negative. So that is our solution right there. Quite a nice little simplification there at the end. And a little tip for the future, or something you can learn from this video, is if you have an integral that traditional methods aren't really working for, you can try to pull something out, factor something out, see how things simplify, and then try it again, and hopefully that gets you somewhere. So thanks for watching this video, and we'll catch you next time. Bye-bye.